All right, guys, here's Precal practice test numbers 9 through the rest. Okay, had a request today. So, number 9, this is in side. I'm trying here. That's a side angle problem because that's a side, that's an angle. So that means if it's obtuse angle, remember that's either one solution or none, but it's not. If it's an acute angle, it could be no solution, could be two answers, or it could be one. So you're going to just draw it and find out what's going on here. So I'm going to draw angle C, which is 29 degrees. They also gave me side C, which is opposite, so it's going to be somewhere over here. Side A is 26. So the first thing you need to find on these every time is the height. So I'm going to take, the way you find the height is you do this number right here, the 26 times sine of your angle. So I'm doing 26 times sine 29 degrees. I'm getting 12.6. So the height's 12.6. So if I drew a line, I'm going to do this right here. If I drew a line straight down here, it would be 12.6. But this side C, is 15, which is a little bit bigger than 12.6. So that would, if I sent it straight down here, it'd go a little bit past 12.6. So if I swung it that way, it would hit there. If I swung it that way, it'd hit there. So what that means to me, because 15 is less than 26, but bigger than the height, that means there's two cases. So I'm going to draw two different side C's. I'm going to do them both in blue. One side C is going to do this. That's side C, which is 15. And the other one would do like this. Of course, then that's 15. So watch my red dot again. Maybe that helps. One triangle I'm trying to solve is the big triangle, that triangle right there. Okay, the big one. The other triangle I'm solving is the other one with the 15. The two triangles have 15s. The triangle with both 15s, really meaningless. Okay, so I'm trying to find that triangle and the big triangle. I need to label it all the way too while I'm at it. Let's see. This angle right here is A, which also means, by the way, that's a B is at the top. Okay, that's what I need. So what am I missing? I need to find angle A and angle A for both of them. So A1 and A2. I need to find angle B in both of them, B1 and B2. I need to find little b, like side B in both of them. By the way, well, let me find the first A first. That'll give away a lot of stuff. So you really have no choice about what to use here. You have to use what they gave you. Okay, so I have no choice but to do this. Sine 29 over 15 equals sine of A over 26. And that's going to give me my big A, my angle A. Okay, when you punch all that in, remember, you have to do inverse sine to get your angle A. And I'll let you round it to the nearest degree if you want to. So angle A is 57 degrees. Now, that's acute, which means it's this angle A right there. Okay, I'm going to call that A1. That's 57 degrees. A2, by the way, is right here. It's obtuse. We talked about in class, those two, the two angle A's, always have to be 180. So to get my other one, I'm just doing 180 minus 57. That's giving me 123 for my other angle A. Okay, so there's my first two sets of answers right there, A1, A2. This angle and that angle. Now I also need angle B. B1 is this whole angle up here. The one triangle is going to be the big triangle. You know, I'll get my dot again, I guess. This big triangle all the way, the big triangle. So big B's at the top. Now, if you look at that triangle, angle A, which we just found, is 57. We know 29 already. So I'm going to take 57 and 29 away from 180 because all three angles have to be 180. And I'm getting 94. All right, so my B1 is 94 degrees. I'm going to do the same thing for my B2. Now, B2, I'm looking at this little triangle. Okay, and what I know of that one is I have a 29 and I have a 123. A 29 and a 123. So I'm doing 180 minus 29 minus 123. I messed up. 180 minus 29 minus 123. And I'm getting 28 degrees. So there's B. So I've gotten 4 answers and only done really one trig thing. So the key has been the picture and knowing that there's 2 answers. So that leaves me with B1 and B2. I'm going to use the same thing here I started with. So I'm going to go sine of 29 degrees over 15 equals sine B, which is 94, over little b1. That's going to give me my b1. Then I'm going to do it again. I'm going to do sine 29, not 92, but 29 degrees over 15, and do my other b. My other b is 28 degrees over little b2. Okay, I'm going to punch those in real quick. 15 times sine 94 Enter divided by sine 29, and I'm getting 30.9 for this one. And I'm going to do the same thing for my B2. 15 times sine 28, enter divided by sine 29, and I'm getting 14.5. And there you go, guys. There it is. Hope that helps some. Let's get the back. All right, exact value, the trig function. First of all, you need to find the reference angle. Cosine 330 is really 30 away from the x-axis, so I'm thinking, okay, what's cosine 30? Everybody knows that's square root of 3 over 2. And think about the quadrant. It's quadrant 4. Cosine's positive. It's just square root of 3 over 2. Secant 3 power 4. I don't know secants. I know secant's reciprocal of cosine. Reference angle, you can drop the top. It's just pi over 4. Everybody knows cosine power 4 is square root of 2 over 2, but it's secant. So I got to flip that. If you flip that, just trust me, you're going to get square root of 2. Now, got to think about the quadrant. That's 3/4 of the way to pi. If you go 3/4 of the way to pi, you're in quadrant 2. Cosine is x. X is negative in quadrant 2. You get negative square root of 2. There's not much work on those. It's just knowing stuff. All right. I know that sounds bad, but that's what you got to do. Number 11. Find the values of the other trig functions of theta if you know secant is 2 and it's in quadrant 4. First of all, secant is 2. We know cosine is reciprocal of that. It's just 1/2. There's cosine. The other thing I know is, I know this. I know cosine squared plus sine squared is always 1. So if I square cosine, cosine is 1/2. If you square 1/2, you get 1/4. Plus sine squared equals 1. All right, move the 1/4 over. You get sine squared is 3/4. Take the square root. You get sine is plus or minus the square root of 3 over 2. Just taking the square root. Okay, now, the key is it's in quadrant 4. Because it's in quadrant 4, that means my sine is going to be negative square root of 3 over 2. So I'm going to put sine theta is negative square root of 3 over 2, which is my cosecant is reciprocal of sine. I'm going to flip that, and I would get negative 2 on 3 over 3. Tangent theta, remember sine over cosine. So if I put my sine, which is negative square root of 3 over 2, over 1/2, the denominators cancel, the 2's cancel. It just gives me negative square root of 3 over 1, which is negative square root of 3. And my cotangent theta, I'm flipping my tangent answer, which would give me this. Fix the bottom, you can't leave it like that. You get negative square root of 3 on 3. So those are all my values. There's my cosine, my sine, my cosecant, my tangent, cotangent. All because cosine squared plus sine squared is 1. It is amazing that is true. That wasn't good. Let me try that one more time. I'm trying to get rid of these answers. It's not wanting to work. There we go. Almost. Sorry about this. Okay, there we go. Number 12. So if a building casts a shadow of 250 feet long, oh my gosh. Find the height of the building if an angle of elevation to the sun is 33.2 degrees. So draw your triangle. Here's your building right there. Here's your pretty building. Don't know how tall the building is. That's what we're trying to find. That's my x. The angle of elevation, which is the same as depression, it must touch the horizontal, so it has to be down there. It has to be. Will always be, because remember, it has to touch the horizontal. And it says the shadow's 250 feet. Guys, please be careful. Shadow's always on the ground. The ground's down there. It's 250. Now look what I have. I have the opposite side and the adjacent side. Opposite over adjacent is tangent, so I'm going to do tangent of 33.2 degrees is opposite over adjacent. And now I'm going to just solve that. I'm multiplying, come on now, I'm multiplying 250 times tangent 33.2 and getting 163.6 feet. That's how tall the building is. Number 13, ask me, is it odd, even, odd, or neither? Now, first thing I notice is the exponents are even. And if I see that, I know for a fact it's not odd. There's no way. So what I'm going to do to check and see if it's even is I'm going to plug in a negative x everywhere I see an x. So I'm going to do that first. I'm plugging a negative x right here, plugging one in right here, and there's nowhere else to plug one in. And that equals y, or f of x. Now, if you raise a negative to an even power, it changes it to positive. So that first one's going to stay positive. The second one's going to stay what it was. Third one's going to stay 7. Once you do that, you need to look at that and say, is it exactly the same as what I started with? Answer is, yeah. That means it is even. So it is even. It could also be the exact opposite that you started with. That would still be even. Okay, so either exactly the same or exact opposite, it would be even. Now, the other way you could do that is you could take this function right here, the very first function I gave you, punch it in your calculator and graph it. If it's symmetric with the y-axis, it's even. If it's symmetric about the origin, it means you can turn it upside down. That means it's odd. Also, if you're going to do algebraically, if it's odd, you would plug in a negative x and a negative y. All right, 14 through 16. It says using the graph, find g of -4. All that means you have to do is you gotta find -4 on your x-axis right here and see where your graph is. Well, it's up at 3, so that's just 3. This one says g of 0. Find 0 on your x-axis. Where's the graph at? It's at -2. Find 2 on your x-axis. Where's the graph at? It's a 0. Or is it? Or is it at 1? I shouldn't have drawn that dot there. Let me look at that real quick. Yeah, it's actually up at 1. Sorry about that. It's at 1. Good eyes on my part. Okay, using the graph, find the domain and range. Remember, domain is how far left and right it goes. This one's going from -4 with a bracket because it touches the -4 right there. And it jumps right there, right here, but that's okay because it keeps on going. And it goes all the way to +4. So your domain from left to right, the x-axis, it goes from -4 to +4. The range is how far up and down it's going, but remember you go down to up. The bottom point down here looks like it's at -2. The very top point right here is up at +3. Brackets on both because it touches both of them. And number 16, using the graph, let me erase these real quick. Using the graph, find all the values for which g of x is 1. Now g of x means y. Where's y 1? That's this line right here. Okay, all along that line is y is 1. So it's asking you what are the values of x where it equals 1. So it equals 1 right there. That's going to be an estimate to me. That looks like it's going to be about, I don't know, let's say -1.3, something like that. It also, right here, we've already got that one. Okay, that was at 2. The x-coordinate is 2 right here. And also hits again right here, which is almost to 4, not quite at 4. So you might want to say, I don't know, 3. It's an estimate, 3. If you put 3.7, 3.8, 3.9, that would give you all those. So that's all there is to it. Hope that helps some study. I'll be here in my room all day. Come see me if you need some help. Would love to help you. See you tomorrow.